Hey guys, so this video is going to be your introduction into scale factors. Okay, so one thing I do want to write a quick reminder. There's just a reminder. And that is all of these terms that I'm about to write mean the same thing. So we've talked about constant rate of change. You mainly seen that in 6th grade. It's come up a little bit in 7th grade as well. Next one which we've mainly been talking about, is our constant of proportionality. Then we've also mentioned slope, and now we're going to talk about scale factor. So all 4 of these pretty much mean the same thing, okay? Just different names for it, but it's all meaning the same thing. So we have this situation here. We have this American flag, and if you're not sure or you didn't know about this part is known as the fly, and this part is known as the hoist. So the ratio of the hoist, which is our height, to the fly, which is our width of the flag, is 1:19. The proportion below represents this information. And remember, proportion are ratios that are, what are they? Equivalent. Okay, so they are the same. So the hoist is going to be over the fly, which is going to equal 1/19. So remember, ratios can be written as that fraction. They can be written with the colon, or they can be written with the word 2. Okay, so it's important to make sure that we match it up with what they belong with. Okay, so this relationship can also be shown using the equation y equals 1.9x. Remember, this equation this type of equation is what we've been using with our constant of proportionality. So the y is going to represent the length of the fly, and the x is going to represent the length of the hoist. So the constant of proportionality is, what is the constant proportionality of this? Think. Hopefully you knew it. 1.9, which is always going to be the coefficient on the independent variable, which again, remember this 1.9 is rate of change, constant proportionality, slope, scale factor. Always going to see those 4 words interchange, but they all mean the same thing. Okay, so if the ratio remains constant, so the same, never changing, and the hoist of the flag is now 2 feet, how can the fly be calculated? What math term would help us figure this out? A lot of you might know it as Ms. Wallen's favorite word. I'm always saying it. Hopefully you knew that it was substitution. Substitution is our best friend. Okay, so here's our equation from above. Y equals 1.9x. Okay, and we're going to use substitution. So think, what variable are we going to substitute in for? Which one are we going to substitute in for? Well, we're given this 2 feet, which is the hoist, right? And the hoist is represented by the x. So we're going to substitute in for the x. So y equals 1.9 times that 2. So we have y equals, sorry guys, the light in my room went off for a second. Hopefully no one got scared. So y equals 1.9 times 2. So do that math on the side, and you should get 30.8 feet. Okay, so that means that when a flag with a hoist of 2 feet, the fly is going to be 3.8 feet. So we can use substitution. We know this. But we can also set up those proportions. Okay, so we're going to do that right now. Using our proportion from above, 1/1 1.9 is going to be equal to 2 over that variable x, because we know that the hoist was 1 here. They gave us that the 2 is the hoist, so we're going to match up what we're given. Okay, then we're going to do our cross multiplication. Do not say butterfly method. We are in 7th grade. We are no longer saying butterfly method. So 1 times x, everyone should know, is going to give us simply x. We do not have to put that 1 there. And that's going to be equal to 2 times 1.9, which we know from above is 3.8. Okay, so that's what we got so far. Well, in our proportion or equation, you can do it either way. You're still going to get the same answer. So now suppose that the proportion used to make the flag is 3 to 5. Okay, 3 to 5. Determine, or figure out what the constant of proportionality, or the rate of change, the slope, the scale factor for this flag, and then we want to write it, the equation to match. Okay, so if my 3, I'm going to give you this one, the 3 represents the x, then that means that my 5 represents my y. Now, what was the equation, or what's the variables? How was that equation set up to help us figure out what the constant of proportionality is if it's not already given to us? Well, hopefully you remember k equals y over x, y divided by x. So all we need to do now is, what's Ms. Wallen's favorite word? Substitute in what we have. So we know that my y is 5 and my x is 3. And this is going to equal, so 5 divided by 3 is going to give me 1.67. But that's only part 1. This was part 1. Part 2, we need to write it in equation form. So my equation is going to be y is equal to 1.67x. Okay? So whatever that scale factor, or whatever they're giving you, the proportion is, we put it into our equation to figure out what the actual constant proportionality is, using the k is equal to y over x. Okay. Now, sometimes a scale drawing is used to represent the data in a problem, or to show the relative size of 2 items. And this relative size just means how one item might be smaller or larger than the other. Okay, so we have these 2 flags. So the fly on this flag, on the smaller flag, is 5. The hoist is 3. On the bigger flag, we don't quite know what the fly is, but we do know what the hoist is. So we're going to write a proportion. So that's 1. Write a proportion to represent the drawing. Then we need to calculate what that actual length is. So we're going to be doing 2 things for this problem. So if you remember from before, the hoist is going to go over the fly. So we're going to take the one that we definitely know both lengths to. So hoist is 3, fly is 5. We're going to have that equal to, well, I wonder which number is going to go on top here. What number on this flag matches the 3? Hopefully you knew it was the 9, which means we're going to put that x right there. Okay, now, so we set up our proportion, which is great, but now we need to actually solve it. So again, we're going to use that cross multiplication to be able to solve. So when I cross multiply 3 times x, and get that 3x. It's going to equal, and then the next one, we're going to do 9 times 5, which is my 45. Okay, now we have a one-step equation, which we learned in 6th grade. So we have this one-step equation that we need to solve. So if 3x represents multiplication. What are we going to use to solve inverse operations? We're going to use the division. So I'm going to divide both sides, draw that line, divide by the 3. Because I want my x by itself, isolate the variable, use inverse operations. This x is going to equal 45 divided by 3, which is going to give me 15, which means the fly up here is equal to 15. Okay. Now let's apply this to some more real-world problems. Okay. So the Gomez family is on a road trip. On the first day, they drove a distance shown as 3.5 inches on a map. The actual distance that they drove was 245 miles. Which is the scale of this map? Well, the first thing that we should do when we have these fractions is to turn it into a decimal. So 3.5 as a decimal is 3.5. Okay. So we need to pretty much, like we've been doing, set it up as a proportion and then calculate it. So we have 3.5 inches for 245 miles. Now, I want to get it for 1 inch. So now I need to figure out what this number is. What is the equivalent of this fraction? Or this proportion. So what do I need to do to 3.5 to get it to that 1 inch? Hopefully you realize we need to divide by 3.5. And what we do to one, we do to the other. So I'm going to divide both of these by 3.5, which 3.5 divided by 3.5 obviously just gives me 1. And 245 divided by 3.5 is going to give me 70 miles, which is answer C. Okay, so I make any fractions a decimal, I set up the proportion that I have, and then I'm either going to be multiplying or dividing to get what my scale is for that map. Okay. Ooh, now we have a nice car problem. So the scale used to make a scale model of a car is 1 to 18. The length of the model is 9.5 inches. So how many feet long is the actual car? Well, again, we want to start by changing this fraction into a decimal, which is 9.5. So that's what we're going to use, is 9.5 here. Okay. Now, sometimes you'll see this, which will be helpful. You'll see model length goes on top over the actual length. Okay, so for this situation, I have 1 over 18, which is my scale factor being used, and I want to get it, or I need to get it to this 9.5. That's what the scale model was. So 1 over 18 equals 9.5, and we're trying to figure out what this missing number is. So kind of opposite of what we did up here, what do we need to do with that 1 to get it to 9.5? Well, we need to multiply by 9.5, because again, what you do to one, you gotta do to the other. Super important. So 18 times 9.5 is going to give me 171 inches. But make sure we read everything, all parts of the problem. This one, how many feet? Well, we have inches. So we're going to need to do some conversion on this. So 171 inches divided by, well, how many inches are in a foot? Hopefully you remember that 12 inches are in a foot. So 171 divided by 12, which is going to give me 14.25. But this problem originally gave me a fraction. Now, not always, but sometimes your answer choices might only be in fraction form. So it's important to, make sure you know how to convert not only fractions to decimals, but decimals to fractions, which we know that 0.25 is what fraction? 1/4, right? So our final answer could be 14 and 1/4, right? Or it could be 14.25 feet, just depending on what our answer choices might be. You could also take it a little bit of step further and do 14 feet 3 inches, because 3 inches is 1/4 of the 12 inches. So you have 1, 2, 3 different possible answer choices for this problem. So it's just important to make sure we pay attention as to what measurements the actual question is asking. Okay, so we've learned about proportions, we've learned about constant proportionality. We're just taking that and we're just using it on some scale drawings. Okay, bye, you guys.